Oh goodness, I hope that you had a carb overload to get your little brain working a little bit better, because we are getting ready to talk about some calculations in part 2 of weight variation with capsules. And I told you that if you're 20 pass and all of them look good, then you just clear it out and you just move on to the next goal for the day. But if one of these tablets fail, then we have to go into part 2 for the capsules. And this is what part 2 is all about. So we said that part 2 is really focused on this concept that the capsule itself could lead to the problems of the weight variation. So if the capsule coating is a issue, we need to eliminate that problem, and that's what this part 2 is all about. So that's why it's telling you to separate the capsule, empty out all of the contents of that capsule as much as possible, and then we are going to weigh that shell. And this allows us to measure just the contents of what's on the inside of that capsule, because if those contents don't have a variation or they pass the variation, then we're good. And that means that the capsule is what led to the first part to fail. And that could be a thing, right? I mean, we're ordering these capsules most of the time from a third party. These laboratories or these manufacturing companies, they are possibly not making their own capsules. They're getting them from another company somewhere else that specializes in making these. And this is just one of those ingredients that they have to use in order to make this finished product. So how does the math of part 2 actually work? So here's an example of what's going on with part 2. So let's say that the capsule, and this is what I'm going to call the raw capsule, the OG, the original, right? So this was me taking a capsule in part 1 and putting on a balance and getting a mass. Let's say that mass was 0.7741. So I've recorded that mass already, right? It's already on a data sheet. And if I've made it to this part 2, that means that something was off in part 1. One capsule failed. So hence, we got to go to part 2. All right, so with these capsules, it's telling me, take that original, and you already have it. 0.7741 grams is what this capsule was. Then you're going to take that apart, and you're going to dump out all of the insides, just in a weigh boat or in something. Just get rid of all of the internals of that capsule. And now you're left with the shell. And we are going to weigh the shell. And that shell weight is 0.1941 grams. So the shell, of course, is matter. Matter is going to make up material. Matter is going to make up some mass of what this capsule is all about. And the next step is, say, calculate the net. It keeps referring to the net, the net, the net, the net, the net. The net is the stuff on the inside. That is what we are after. That is really what we're calculating here. So I'm going to take the capsule, which is 0.7741, and I'm going to subtract the shell weight from it. And when I do that, I'm going to get 0.5800. That is the mass or the difference between the capsule and the shell. So it looks like a little more than half of a gram of material is on the inside of this capsule. And that is referred to as the net difference, right? All right, so when I do that for every single tablet, right, we got an individual mass for every capsule. We're going to separate every one of them one by one. We're going to dump out the contents of each one by one. And then we're going to weigh the shells, each one of them one by one. And I'm going to create this uglier spreadsheet that has this difference calculation on it. So I'm just going to do one capsule for an example, but keep in mind there's going to be 20 of these, all right? If you're lucky. Oh God, what does that mean? Ooh. All right. So next it's going to say, well, now calculate the average. Calculate the average of the nets. So this was the net for just this one capsule. That is it, nothing more. So let's say that I did this, and I did this for a bunch of them, 20 of them, right? I'm going to have 20 data points here. So I'm going to look at these nets, these differences, and just like before, I go to Excel and I type in equal, AVERAGE, and I highlight all of these differences from all of these capsules, And I'm going to have an average of 0.6189 gram. All right, that's great. So now what my job is to compare the net from each one of the 20 capsules to that average. So I'm going to compare the 0.5800 to the average 0.6189. And I need to make a judgment call. I need to say, does this pass or does this fail? And I've got to make the judgment calls 20 times for all 20 tablets because we're doing them individually. That's what this is all about. So it's going to tell me to take a difference between the net and the net average. So that's what's going to happen in the next line. I'm going to take the average, 0.6189, subtract 0.5800. I take that difference. Make sure that you take the absolute value of it, folks. That's what we're after here. So the absolute value, you should always get a positive number. If you get a negative number, you just subtracted the wrong way. It's no big deal. Just erase the negative. That's all that absolute value does. And that difference is 0.0389. So that is the difference from the individual capsule to the average. It's almost like I'm doing a standard deviation, right? To calculate standard deviation, that's one of the first tasks. You have to take your average first, and then you subtract the individual data point from the average every single time. Now, you do more stuff with it than that, but this looks very similar to that, right? So that gives me a difference, and it says that all of my capsules should be within 10% of the average, right? So that is my threshold. That is what I need to use as a judgment call to say, did this thing pass or did it fail? So 10% of the average, my average was 6189. So 10%, 10 divided by 100 is 0.10. That's 10% right there. So 10%, 0.10 times my average, 0.6189, is equal to 0.0619 gram. This is going to be the allowable limit. That means that your difference could be up to 0.0619. If it goes over 0.0619, no, that capsule is going to fail, and you need to record it as a failing moment. We hope that these capsules will pass. I don't know, but we'll see when we fill out the data sheet or the spreadsheets or whatever they give me to kind of key in my numbers. But this is how I determine what passes and what fails based on the set of data that's given to me or that I've generated. So the difference here is 0.0389. The threshold was 0.0619. And that means ding, 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 the capsule passes because my difference is less than 10% of the average. That's how we make the judgment calls with part 2. All right. So if I pull up part 2, we're going to kind of keep going and we're going to take a look at this in more detail. Here at the end of the first kind of full paragraph, and the paragraph that we hate it to do, then determine the difference between each individual net content and the average net content. We just went through that example. The requirements are met if not more than 2 of the differences are greater than 10%. Woo! All right. So the difference, I compare that to 10% of the average. As long as that difference is lower than that 10% threshold, we are good. Pass, 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 pass. And this entire thing passes if not more than 2 of the differences are greater than 10%. So out of the 20 capsules, 2 of them can fail. If 3 of them fail, I go to part 3. Oh, God. Remember, I told you no one wants to do part 2, much less than part 3. You're getting ready to find out. But if 2 or less fail, then we can stop here. We don't have to do any more. Don't have to do any more at all. Great job. The problem, though, is that another threshold is in place. And that threshold says, in no case should the difference be greater than 25. So let's say that I had one that failed. One capsule failed. By looking at checkmark A, no more than 2 or greater than 10%, I would look at that and say, well, one capsule failed. That's below 2. I'm going to pass this data sheet. No. That's not how this works. One bad apple ruins the whole bushel. So if I take a look at that one that possibly could fail, and let's say that one fails, and that one fails by a difference greater than 25%, that is like the thresholds of the thresholds, the mother threshold. That 25% is. So even if you just had one failed, that's okay halfway. But is that one also less than 25%? Because if it's greater than 25%, the entire batch fails. No matter what, the entire batch fails. Again, one rotten apple. So if you make it through this, you had to do part 2, and you do part 2, and you get through part 2, and it still fails, what on earth begins to happen? Oh my God. Let's say that I get to part 2 and more than 2 of them fail, but less than 6. What on earth? Yeah, if you get to part 2 and you did all this work, the USPNF is going to be like, oh gosh, you did all of this work and all the data and all the masses and all the numbers and all the calculations and all the spreadsheet work. So if more than 2 of them fail, you're not going to close up shop yet. We're going to do another benefit of the doubt, and we'll go to a part 3. And if part 2 fails, and let's say 4 capsules fail, because remember, no more than 2 can. If 2 or less fail, part 2 is over. You don't have to do anything else with it. You call it a day, pass the batch, and you go to your next job for the day. But if more than 2 fail, but no more than 6, then we have to do another 40 capsules. Do you think I'm lying? Do you think this is busy work? If more than 2, but more than 2, but no more than 6 capsules deviate, determine the net contents of an additional 40. Yeah, I hope they're going to pay me. I hope they're going to pay me a long, long time, because I'm going to be here forever. So this means I'll take 40 more capsules. I will weigh all of those 40 individually, one by 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 one. You get the picture. Then I'm going to have to separate all 40 of those capsules one by 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 one. Then I'm going to have to take the individual masses of the shells one by 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 one. God, that all ran together. And then I'm going to have to take the differences of those shells and the capsule in the original form, one by one by one by one by one by one by one. And I got a report on those. So now I have a total of 60. I've got 20 from part 2, and I've got another 40 from, they punished me. That's what they did. They punished me and my lab data, and they are requiring me to do 40 more. So now I've got a total of 60 60 in a spreadsheet. God, this sounds so much like a Tracy Lab. It's not even funny. I don't even know why he didn't give me a 60 individual data point spreadsheet. I'll do that for next year. But determine the 60 deviations from the new average, and the requirements are met if not more than 6 of the 60 have a difference than greater than 10%. So we go back to the same calculation at this point. So basically part 2 is done all over again, but now double. So I'm getting 20 from part 2. The calculations in part 2 are all the same for part 3. There's no difference. Part 3 just basically tells me to do 40 more of these. So if I do 20 and I don't separate them in the beginning, and I do all 20 of those and they work, woo-hoo, woo, check mark, that passes. Get me out of this bog water, because this is going to be horrendous if that first 20 does not pass. If some of those do not pass, because again, keep in mind what it says, if all do not pass, okay, if one rotten apple fails, I go to part 2. I go to part 2. Now I take those 20 and I'm going to have to separate them, clean the shells out, weigh the shells, do the differences, blah, 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 blah. And if 2 of those, more than 2 of those fail, then I go to part 3 and I do 40 more. And then I've got a total of 60. And out of those 60, if not more than 6 have differences greater than 10, woo, we are good. That passes. But in no case does any one of those 60, exceed a 25% threshold. That is the mother threshold of the bunch. 25% in all cases so far, right? So this is the story with hard shell capsules. Good news, if you did this in real life, your spreadsheet's going to be made. You key in the individual masses for the OGs. And then if that does not work out, you key in the masses also of the cleaned out shells. And then it will do all the masses for you. Everything gets updated. You're on your way. But bad news is that if you're taking an online assignment that's based on this particular measurement of weight variation, General Chapter 2091, they're probably going to ask you to do some of these calculations on your own. So calculate the average of the following masses of the capsules. And based on the average, does the capsule pass? Do any of the capsules fail? Blah, 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 blah. And now you know how to do those. You've got kind of 2 examples here. Our first one was here, where we took the average and we calculated the 90% and the 110% threshold. And then the second was part 2, where we did the differences, because we're looking at shells and we're looking at OG capsules. So we take those 2 and subtract them to get a remaining content mass. And that content mass is going to be subtracted from the average masses of the contents to get a difference. And we are looking at the differences compared to 10% of the average. So take a look at these 2 example problems. I'll almost guarantee you'll find that in the online assignments. It will force you through those calculations, and it will make you work through them. Part 3, well, there's no story difference. It is the same exact thing. But now we do 40 more to get a total of 60. And then our passing score is no more than 6 have differences greater than 10. But keep in mind, any one that goes over 25% threshold, it automatically fails the entire 60 tablet or capsule batch here. Automatically fails everything, no matter what. Next up are soft shell capsules. How are these any different? So soft shell capsules, this is almost like if you've ever taken a vitamin E tablet or capsule. The vitamin E capsule is filled with this like jelly liquid on the inside. Most of the time, these are going to be like fish oils. Vitamin E's are made this way a lot of times. Vitamin B's are made this way a lot of times. So this is something that's a little bit liquidy on the inside of the capsules, but it's still a capsule. And it's still defined in the USPNF as a proper procedure that we've got to go through in order to do this math. So how are these any different? Well, I'm going to make this very easy for you. It's the same for the hard shell. There's no difference. So you start off with 20, and with those 20, you're going to individually weigh those 20 as they are, the OG formats, just like before. And then you will calculate that threshold. So again, 90 to 110%. That is what we're after. Does any capsule fall below 90, or does any capsule go above 110%? Yes or no? If any one of those fail, you go to part 2. So that means I need to take the 20 capsules and I need to separate them. Yes, that is right. You need to separate them. But wait a minute. How do you separate things that look like this? Because there's liquids on the inside from things like this with solids on the inside. There is no difference, just a slight modification. You're going to have to cut these capsules open with a scalpel or a pair of scissors. You're going to have to squeeze out all of the inside material. Well, no, we're not going to be squeezing, because we can actually break the capsule or disturb the capsule in some form or fashion. So what you're going to find out is that we do have to remove the inside, but we're not necessarily going to do that by squeezing the capsule's juice out of it, because that's kind of what it is. We're going to use a proper solvent. And that solvent is typically provided to you in some form or fashion, whether it's an SOP or a method. The solvents could be anything that will dissolve the interior, typically oily, organic-y types of contents, way, way better than the outside capsule. That kind of soft jelly-like material on the outside, or plasticky-like material on the outside. That solvent will take away everything on the inside, but it will not dissolve the actual capsule shell itself. So then we're going to jiggle those capsules around in that solvent. That removes all of the interior coat, and then, or interior contents, and then the shell is left over. And we have to evaporate the solvent from the shells. A lot of times this is simply done by laying the shell out on a petri dish or a container and just letting the solvent evaporate. That's really all that we do. We don't even need heat. We just let it naturally evaporate for 30 minutes or so on the lab countertop. And then, just like before, we go and we weigh the shells, and then we calculate nets, and the math is all the same. There is no difference from that point. So yet again, please, oh please, oh please, oh please, when I take these 20 tablets, let them all fit and pass within the 90 to 110% threshold. Because if they do, I do not have to cut these open, and I do not have to use solvents, and I do not have to dissolve those interiors out of the shell, and I don't have to dry the shell, and I don't have to weigh the shell, and I don't have to do the differences of the shell, and I don't have to do averages of the shell difference, and I don't have to do that comparison. If the first round passes, we are good to go, and that's what I hope for every single time. But if not, we do another 20. We cut them open, use a solvent, dissolve the stuff. You have the shells left over. Allow the shells to dry, and then mass the empty shells. And then the math is all the same. The criteria here is exactly the same as before. There is no difference. What we're after here is not more than 2. Should actually fail. If more than 2 fail, guess what? You go to part 3, and guess what part 3 is going to do? Do 40 more! All right, so here we go. Soft shells. Proceed as directed under the hard shell capsules. But determine the net weight of the contents in individual capsules as follows. Weigh the intact capsules individually, just like before, taking care to preserve the identity. Cut open the capsules, just like before, but this time using some scissors or a scalpel or some type of blade. And then remove the contents, not by dumping them out, but by washing the capsules with suitable solvents. That dissolves everything on the inside, it washes it out, rinses it out, and now you're left over with just the capsule material itself that is in soft form. Allow the occluded solvent to evaporate from the shells by setting it at room temperature for a period of 30 minutes. So you don't want to weigh the capsule shells right off the bat. You want to give time for the solvent to evaporate off because that will change your mass. And then weigh the shells, calculate the contents, and the requirements are stated as they are under the hard shell capsules. So for part 2, if I'm doing soft shell, no more than 2 should be greater than 10% of the average. If any one is greater than 25, it also automatically fails. Does not matter. Then I go to part 3 with soft shells, just like hard shells. If this fails, I go to part 3 and they're going to tell me to do 40 more. And I repeat the process all over again. But now I've got 60 data points to worry with. 60 data points that I hope will pass or fail, because that is when this test is now over. Formally, that's when this test is over. So soft shells, no difference as hard shells. What about tablets? Tablets are anything that is in hard, what we would call pill form. So these are going to be things, very often traditional medications are made this way, even down to like your aspirins that you see over the counter, that is in a tablet form. Your Motrins are typically in some type of tablet form. These are very few times in between are capsules. There are capsules that are out there over the counter, but keep in mind these are dietary supplements, not over-the-counter prescription medications, not prescribed medications, dietary supplements only. So there are some dietary supplements that come in this form of a tablet, and you'll probably use some of these with maybe like our melatonins that we're going to have you to measure out, and so forth. So the tablets are going to be hard pressed. There is no like capsule on the outside that we can take apart and dump out all of the interior contents. It's all just kind of pressed and molded together, and binders and stuff make this tablet compact and hold together this way so it doesn't just fall apart on you. Tablets can come in all forms, shapes, and sizes and colors. So here's the rainbow of Skittles of tablets, and then here are just different shapes of tablets that can also be formed and given inside of a dietary supplement bottle. Doesn't really matter. It's a tablet no matter what. So if we go to tablets, it says weigh 20 individually and calculate the average weight. So very similar to the capsule first part. If the requirements are met, if the weights of no more than 2 of the tablets differ from the average weight by more than the percentage listed in table 1, and no tablet differs by more than double that percentage. All right, so here is table 1. This is what they're referring to, and table 1 is broken down by tablet size. So if your tablets fall in the range of 130 milligrams, see the unit, 130 milligrams or less, that's 0.130 grams. So 130 milligrams or less, your percentage is going to be 10% allowable. If you have a tablet that goes between 0.13 and 0.324 grams, or 130 to 324 milligrams, they mean the same thing, then your target percentage is 7.5. And then if your tablet is more than 324 milligrams on average, which is also 0.324 grams, then your allowable difference is 5%. So what you're seeing here is that the smaller the tablet, the larger the percentage they are giving you to abide by, because they think that's fair. Tiny tablets are probably a little bit smaller, harder to manufacture maybe, who knows, but they're giving more of a cushion, and it's a smaller number. So slight changes with small numbers make big differences actually. And the larger it goes, well, slight changes here are not going to make that much of an impact as far as percentage goes. So that's the reason that these percentages are going to change based on tablet size. The bigger you go, the difference has less of an impact on the percentage. And because it has less of an impact, they believe that the percentage allowable should go down, because it's going to take a big old whopper of a change to get that to be different than 10% versus a little tiny smaller tablet, if that's what you're working with. All right, so the directions again are going to say weigh 20, calculate the average, just like before. Then use that average percentage, use that average weight, calculate a percentage individually on each tablet, and you hope that it doesn't go over the threshold that's in the table. No more than 2 should violate it. And no more than any, not one tablet should double the percent. All right, so let's do kind of an example problem here, and let's see what we're working with. Let's say that our tablet here that we've measured out, our individual tablet, is 0.2521 grams. This is our tablet, the OG tablet that I have weighed on a balance. And let's say that I did 20 of these, and let's say that the average of that 20 ends up being 0.2881. There we go. This is the average of all 20. I've got to compare these two things together, right? So what they're going to do is that they're going to take the average weight, 0.2881, and they are going to subtract the tablet mass. Again, you got to do this 20 times because you've got 20 tablets. And then they're going to divide that, because that's your difference. Then they're going to divide that difference by the average tablet weight. So 0.2881. And then they multiply by 100 in order to get percentage. So if you take the difference between the average and the individual tablet, then you divide by the average, then you multiply by 100, what you're going to get with this particular problem is 12.5%. So does that tablet pass, or does that tablet fail? Well, we got to know the reference table. It looks like our tablet mass is about 0.25 grams. That's also 250-ish milligrams, right? That's what that is. Don't believe me, multiply by 1,000. That'll convert it to milligram. So 250-ish milligrams. So if I go to the table, 250 milligrams will kind of be right in here from 130 to 324, right? This right in here is the area that we're working in based on our tablet mass. And it looks like my threshold is 7.5%. If anything is over 7.5, it fails. But also look at what it says. And for this example problem, it is, right? 12.5 is greater than 7.5. So absolutely, this capsule will fail. So this criteria says no more than 2 should differ from the average. Well, this one already is differ from the average percentage that's given in the table. But no tablet should differ more than double that percentage, not 1. So based on this, 7.5 is the threshold. This capsule will fail that threshold. But will it be enough to fail the entire 20 on its own, at face value on its own? Well, you need double that amount. So 7.5 times 2, that is going to be 15%. So this is not quite 15. It's less than 15. So it's not going to automatically, by default, fail the entire batch of capsules or tablets, in this case, that I'm weighing out of a dietary supplement, but it came awfully darn close. And if it was over 15 for this particular case, it would have. This 130 or less, if that is greater than 20%, it automatically fails the entire batch of tablets on its own. I don't need to do anything else. It's just automatically going to fail. All right, so with that said, does it say anything else? It just says, okay, here I've got a tablet. No more than 2 of the tablets differ from the average weight by more than the percentage listed, and no tablet differs in weight by more than double of that percentage. It doesn't give me a part 2. It doesn't give me a part 3. That is where this stops. So tablets are way more comfortable doing than capsules, because capsules is going to force you to take the capsule apart and just get the mass of the coating or the capsule, the shell that you're going to have to do some calculations with. The tablets do not do that because I can't separate anything. There's nothing on the inside of a shell. It is the tablet. You get it all, one form or another. It's everything included. One-stop shop. That's what you're getting with the tablet. So this is literally just measure out 20, do some calculations, and hopefully no more than 2 fail that threshold, whatever threshold that might be. Coated tablets. What are coated tablets? Coated tablets are typically something that have like a harder shell on them. That's what these are. So a coated tablet is very similar to just a regular tablet, but it does have this harder shell. This harder shell, you can kind of click on it with your fingernail. It might seem like a harder, more plastic type of coating, even though it's not plastic. But to you, that's what it will seem like it is. And that harder shell, we've got to treat a little differently because that shell is coated on the surface of the tablet once that tablet is pressed. So the tablet is pressed in that form, and then this harder coating surrounds that to help keep that tablet together so it doesn't break up. Or maybe they want to extend the tablet and they want it not to break down immediately, but they want it to have maybe an extended shelf life, or not a shelf life, but an extended release time once you swallow it down the hatch and get it inside your stomach. So the harder shell takes a little bit time. It starts to slowly disintegrate. It starts to slowly break apart. And that shell is additional mass that is used in the manufacturing process, and that could contribute to weight variation if we're not very careful. So the coated tablets, that's what these are. We are going to repeat the process for uncoated. So we're going to take 20, we're going to mask those 20, we're going to see if those 20 pass. If those 20 do not pass, there is an extra thing that we do, kind of like capsules. There's an extra step that we've got to go through before we just say, no, absolutely no. I said no, this batch is going to fail. So this part 2 is not as difficult as the capsules because there's really nothing that we can break apart and empty the inside contents out of. This is a shell that is hard pressed that is on these tablets. So what happens here is that we place 20 tablets in a beaker of water at 37 degrees. Think dissolution here. If you've done the dissolution test, 37 was kind of that temperature that we talked about. So those 20 tablets are going to go into a beaker of water at 37 degrees, and we're going to swirl them just a little bit. We're not talking like stir bars. We're not talking about shaking them up and down like you're making a cocktail. We're going to say swirl the beaker, be very gentle with it, be very baby-like with it for 5 minutes. And then look at those tablets. Did they start to disintegrate? If they started to disintegrate and basically break apart, because that's what this is, break apart. If those tablets begin to break apart, then you want to repeat that entire process, but for a shorter amount of time. You do not want the tablets to break apart on themselves. You want the tablets to be intact, but what you're after here is for this harder shell that's on the outside, you want that harder shell to somewhat dissolve a little bit. You want it to dissolve to a point that the tablet is still together. It's not fully broken apart. It's not fully disintegrated, but you want some of that outside coating off of there. So if that is the point at which you are after that 5 minutes, that is great. What you do is that you take these tablets out of that water, you dry them at 50 degrees in an oven for 30 minutes. You get rid of that water. And then you repeat the masses. These masses are going to be a little bit lower. And the reason is because the harder shell coating has now been dissolved a little bit, but again, not to the point that the tablet fully disintegrates on you. So we dry them in the oven, 50 degrees, we take them back out, we let them cool, and then we do the individual masses again. We do the same thresholds again, the same calculations in the math all over again. All right, so that's how a coated tablet would be a little bit different than the uncoated tablets. Next are chewable gels. These are also a change in the USPNF. The change was recent, but it's still been, a handful of years ago. Dietary supplements can come in this form as well, just jellies or gummies. We call these chewable gels. And they can be dietary supplements in forms of multivitamins or melatonin or anything that you have a hard time swallowing a capsule or a tablet for. So what about chewable gels? What do we do here? Well, we're going to go through and we're going to take an equal number of units and we go by color and shape. So if I get a jar that's got yellow ones and pink ones and purple ones in them, I don't want to include those into a mix. I want to pick out maybe all of the purple ones, and I'm going to work with only the purple ones with that particular shape, because those flavorings are additives, and those additives could vary from tablet to tablet, or in this case, chewable gel to chewable gel. And I don't want to take that risk. So if I look at the container, I'm going to pick out everything that looks the same. I hope that it looks like this, where everything looks the same. It's all uniform. And I just grab 20 of those tablets. It says actually 20 to 30 though. So they're using your judgment call, at least 20, but no more than 30. You put them onto a balance, you weigh them individually just like before, you calculate an average just like before, and you want to make sure that the difference between your chewable gel and the average, you want to make sure that that difference, you take the absolute value of, divide it by the average, just like you did before, multiply by 100, just like you did before. You want to make sure that that difference is not greater than 7.5%. If more than one of those fail, the test fails. And there really is no more to do other than trying to do some more of them. So if more than one is over that 7.5%, you're going to fail that first round. And if one fails, then you're going to have to repeat it, doing another 20 to 30. And what you hope in the end is that none of them in set 2 differ by more than 10%. So again, different stages here. And the first stage is 20 to 30 first, and hope that everything matches 7.5%. If one of those fail, then you need to do another 20 or 30 of them, do the same calculation, but this time in that second set, in that second 20 to 30, you hope that none of them differ more than 10%. If more than one of them fail though, the entire batch fails and it does not pass the weight variation test. All right, so a lot of math here. Again, it's all about averages. It's all about the differences. It's all about percentages. So hopefully you can use a few of those example problems that we did throughout this past 45 minutes of spending time on weight variation 2091 and get prepared for the online assessments, because this one's probably going to be a little more math based, because it seems like that's what this is all about: massing them, averaging them, taking a difference, comparing it to a percentage, and so forth. Here's the chewable gels. Notice that's all highlighted with triangles in the front and the back end. That was updated in 2019 with the inclusion of that. Chewable gels meet the requirements of the following tests with respect to weight variation. Individually weigh an equal number of units of each color and shape to obtain a total of not less than 20 and not more than 30 weights, and calculate the average. The requirements are met if no individual weight deviates from the average by more than 7.5%. If more than one unit exceeds the specified limit, the test will automatically fail. If one unit, though, does fall outside the limit, then repeat the procedure with an additional set of 20 to 30. The requirements are met if none of the units tested in the second set differ from their average weight by more than 10%. So that is the process of a chewable gel. Again, math-wise, very similar to some of the others. In the laboratory, if I get you to do this, most of the time I get you to focus on tablets, and I get you to focus on a uncoated or film-coated tablet. That basically means weigh out 20. If it fails, it fails. No follow-ups, nothing else to do outside of that fact. If you're unlucky and maybe I just hate the class, then I'll get you to do some of the other versions just to put you through torture a little bit. But for the most part, we stick with the tablets. I think that gets the point across and gets you to understand some of the calculations, at least, leading up to the weight variation of 2091. All right, so that one's now finished. Weight variation of dietary supplements. Keep in mind, dietary supplements only of the USPNF. And how we are okay with things being varied in masses. But still, there's going to have to limit. There's going to be a strict guideline on what passes and what fails. And it looks like 10% weight variation is going to be the judgment call. If it's more than 25% variation, though, no matter what, whether it's a capsule, whether it's a soft shell, hard shell, tablet, coated tablet, uncoated tablet, all of those have a strict threshold of 25%. If any one of them is greater than 25%, the entire thing fails. It does not work, no matter what the other material might calculate out to be too. So that is the mother percentage that you are after. 25%, no more, but 10% or less is going to be the ideal. All right, so good luck on the online assignment for weight variation. I talked enough. I think I'm over for the day. You might be over this for not just today, but for the entire semester. And if so, I don't kind of blame you. But there's probably more online Canvas stuff than this. So stay tuned. See what else shows up. It's like a little Easter egg hunt sometimes, isn't it?